Hello, I'm Hugo and I'm going to be giving a quick beginner's tutorial how to make a simple snake game in Pixi.js. So this is the snake game we're going to be making. The version we're making is a little bit more simple. This follows the cursor in a very awkward manner. That's something I need to improve. And the version that we're going to be working on is keyboard only. Make sure you have VS Code and Node installed. What we can do is head over to Pixi.js Quick Start Guide, and this Quick Start Guide provides us with a very convenient command to generate a project for us. Copy, then we can head over to our projects directory. In this case, I have created a folder called snippets, and I'm going to convert this into a repository, and I will give the link in the description so you can see my code. I can right click and press open in terminal. For some reason you cannot see the open in terminal, or if you're using another platform, what you can do is open a terminal and then type in the command cd to change the directory. So cd into this folder. So I'm going to copy this again, and now we can run the command in the terminal. What we are doing is we are generating a project already for us. So I'm going to call this Pixi.js simple snake game. I like to put the dashes because this is going to generate a folder, and it's a bit more convenient if the folder doesn't have spaces in it, because when you're referring to it in the terminal, it will save you for later. So press enter, bundle the templates. I like to use Vite, and that's all. I just pressed enter like 3 times and I'm here. Now we can cd into the project and we can run the command code dot, which will open VS Code. So here we are in VS Code, and the first thing I like to do is open the terminal. So it should look something like this with the terminal open. And the first thing we can do is run npm install to install the dependencies. What this npm install is doing, it's installing dependencies into this node modules folder. And you can see the dependencies being installed here. It's going to look at this package.json and install these packages. So now that we have the dependencies installed, look here at the scripts. We have the start, build, lint, and dev. Let's run build first, npm run build. And this npm run is running the build script. So firstly it's linting, then running tsc, which is the TypeScript compiler, and then Vite build. We can see everything has been built successfully. We can go ahead and run the project. So we can run it with npm run start command. And here we go. This is the Pixi.js hello world, and we have that working. Now we can get started with our own snake logic. It's going to be a snake rather than this rabbit going around in circles. Now let's head back to VS Code. We can open src, which is the source folder, and we can open main.ts. And this is the logic for the Pixi rabbit. This file is being consumed by the index.html file. And so this is our index.html, which is referring to the main.ts. When we run the npm run build command, it is generating a new version of this index.html, which is compiled, you can say. And we can see here that it has compiled the HTML, and now it points to a JavaScript file. And so this JavaScript file we can open by looking on our left and finding index dash. And this is what the compiled version of our project looks like. It looks very messy and it's not human readable. Okay, so we can close that and we can look back at the main.ts file. So the first thing that we're going to do is try to draw a square on the screen. Let's go ahead and create a variable which can represent the square size. We can call this the grid cell size, because this is going to be the size of the snake eventually. Let's make this equal to 20. So now we can go here, and instead of creating a new sprite, we can go ahead and create a new graphics. And a graphics is a type of object, and this can be a square. So we will go ahead and call rect. A rectangle can be a square. By the way, what this did is this automatically added the import for Pixi.js. This rect is expecting 4 arguments, the x, y, width, and height. Let's create the x and y at 100. So it's not going to be completely on the corner, it's going to be in the center a little bit. And this width is going to be the grid cell size, and the height will be the grid cell size as well. Now we have to specify a color for this so we can see the graphic. This can be white, let's say. We can delete this anchor point, and let's call this a square for now. We have a warning here that the texture is declared but not used. We can go ahead and clear that. And at the top here, we can clear this too. So now we have a square being set at this position But then we're also specifying the position here. So what we don't want to be doing is calling this new graphics rect command every time we want to draw something, because this could lead to an excessive amount of calls to the GPU. So what is a better practice is to set this to 0, and then we can set the position here to 100, 100. And then this is going to make it super easy to move this graphics around in the future. And I believe that is good. It's going to be rotating. Let's leave that for now, and let's see the progress. By the way, I believe this npm run start command is looking to see if we make changes. Let's see if it is working. Here we go. So as you can see here, the square is rotating around the corner, but if we want that to rotate around the center, we can change the pivot. I'll show you how we can do that. So after we've created the square, we can set the pivot to equal half of the width and height. So this is going to take in a vector, and we can set grid cell size divided by 2, and then the y as well for grid cell size divided by 2. And this is going to be pivoting around the center. So when we open this back up, it is pivoting around the center. And that was just for fun. I don't think we actually need to do that. Now, what we can do is think about how to represent the snake. I think we should create a type called snake, which will have a head, and this head can be some kind of coordinate with an x and y. And then the snake can also have a body, which can be an array of coordinates as well. Let's simplify this by creating a coordinate type. And this type is going to contain the x and the y, and then we can use this type in the snake. By the way, sometimes ESLint can be a bit harsh and will say that you're having errors already here because we are not using this type. What I sometimes like to do is go over to the ESLint config and then change the ignores to everything by this star. And this ignores everything, which keeps ESLint happy. ESLint is some kind of extension. It makes sure the code is linted, meaning that it makes sure that we're not doing anything too silly, I guess. Silly as in creating a type that we're not using. But it doesn't know that we're still developing the application. So sometimes I like to completely disable it so we have peace for the moment, and then I will go ahead and re-enable it later. So this snake can also have a direction. So we can go ahead and create a direction enum, which contains the up, left, down, and right. And then we can store this here as the direction. So now let's go ahead and instantiate this snake with type snake, assigning an empty object. Now we have an error. It's missing the properties. So what I like to do is control dot and then add missing properties. And now we can specify the coordinates. The head, let's set this to 100, 100 for now. And then we can set the direction to up, leave that as default. So we should use this snake somewhere already. We can go ahead and change this hard-coded 100 here to the snake head X and then the snake head Y. Now, if we check the progress, we should still see the square going around in a circle. So now that we've seen nothing is broken, what we can do is cut this and then paste it into the ticker section. And we have the position being set here. This is not going to change the behavior at all now. It's going to call this for every tick, and it's going to be useful eventually. Let's delete this comment. Let's delete these comments. I'm going to delete all the comments because they are pretty useless. I don't think it's useful to have a comment saying initialize the application when you can see the function is called app.init. The comments should be documenting things that aren't immediately obvious. To be fair, maybe this is useful. This isn't for the animate update, so we'll leave that. Now we can remove the rotation as well. And also we can remove this ticker argument that we're getting because we're not going to need it. This is used when there are physics, and the physics need a time delta that you can use to try to guarantee that the behavior, the speed is going to be the same on different devices, no matter how fast the device is running. You might want to try to ensure that the speed of some object is moving if you have a slower frame rate on another device. But for the snake game, we are going to fix this to 10 frames per second. So speaking of fixing this to 10 frames per second, let's fix this already in the app.ticker. So we can set the max FPS to 10. This is setting the maximum amount of times Pixi.js will call this function. So this is going to be useful for our snake, where we are going to be iterating our snake by 10 frames every second. So now that we've set the max frames per second to 10, what we can do is actually iterate the snake already. We can go here and let's leave a comment called logic, because this is going to be the logic and this is going to be rendering. Because what this is doing is this is setting the logical snake to the Pixi.js renderer. So this isn't really any logic, you could say. This is just passing the data to the renderer. So snake X can be incremented by the grid cell size, for example. And let's see how that looks. And here we can see it moving diagonally for some reason. And this is because I already have a bug and I have set Y. We can see that we have the rectangle moving in a direction to the right. So since this is working, what we can do is extend this to look at the direction and then move in the direction that we are telling the snake to move. So for example, an if snake.direction is moving up, then it will set snake.head.y minus equal to the grid size cell. We can do the same for all of the other directions, and I think it should look something like this. Let's fix the formatting. And now we are moving up because we have set the direction to up, and that looks good. Now if we're moving down, we set the direction to down. Perfect. Let's check all the coordinates. Looks good. That works fine. What would be cool is to actually change the direction with the keyboard input. We can do this by adding a listener. So key down. And then we can add a callback here with the key press. So this key press, if we look at the key, and then if it is the arrow left, we can set the direction to left. By the way, if you're wondering how we can assign while this is still a const, what this const means is we are not reassigning the snake itself, but we are allowed to change properties such as the direction because it is the same snake that we are talking about. So for example, if we try to do snake equals something, we will get an error because it is constant. It still allows us to change the properties. Okay, so with that out of the way, let's go and check the other key presses, and then let's see if this is working. And there we go. When we press the arrow keys, we can see that it is changing the snake, or the head at the moment. So now we can go back to VS Code and think about adding the body. And I just realized before we add the body, let's add the food first, because it'll be easiest to, after we've added the food, we can increase the body with this food after it's eaten the food. And what we can do is this food can be a coordinate, and this shouldn't be const because it will be reassigned to, and let's set this to a default of 200 by 200. So the idea is once we eat this food, we're going to increase the body of the snake. Let's render this. Let's create another graphic for the food. We can call this food graphic. We have to call it something other than food because we don't want a collision. And let's make it red because it's an apple, for example. We have to add this food graphic into the stage. We can set the position of the graphic here. So we have the food graphic position to be equal to the food.x and then food.y. Also, this can be called the snake head rather than a square. Now let's see if this, yes, this has produced the red apple on the screen. Now let's add the abilities so we can increase the snake size when we eat the food. So what we can do here is before we check the direction of the snake, we can check if the head is colliding with the food. Snake dot head is equal to the food dot x, and then we have to check the y as well. Okay, and so here we should be getting a collision. Let's console log this out to see if this is true. Food. We can open the terminal by pressing F12 or pressing inspect, right click inspect, and then you should get something like this. We can go over to console, and then I'm going to refresh the page so I get the snake back, and then when you eat it, you get the food. So one thing I've noticed here is the snake goes under the food. Let's reorder the snake so the head is on top. it looks a bit nicer because the snake is the one eating the food rather than the food eating the snake. And so here we go, we can see that the collision is working, we get the food output. Now let's go back to VS Code. So now in VS Code, what we want to be doing is pushing to the body instead of printing to the terminal if we eat the food. So we can do this by doing snake.body push. It's easiest for now if the body is going to be pushed in where the head is currently. Well, we have this x.head.x.y. By the way, what we're doing here is creating a new object. We don't want to be pushing in the snake head like this, because then that means if we change the body, it is going to still refer to the snake head, and it will cause problems down the line. So we need to be making sure that we are instantiating a new object rather than referring to the existing object. We're not going to see anything yet because so far we're only changing the logic and we haven't changed the renderer. We need to update the rendering section so we can actually see the pushed in body. And now that I say that, we're still not going to see the body because it is going to be conflicting with the head at the moment while we still haven't iterated the body. So what we can do is create some kind of container for Pixi.js. Pixi.js has a type called a container, and if we instantiate this can store the snake bodies. And then we can add this to the stage. We are adding it after the head, and then now we can create a new graphic for the body, and then we can push this into the container. Let's copy this, and then we will push this into the body graphic. So let's make this gray. By the way, I'm conflicting the advice that I suggested before by instantiating a new graphics object for each frame. This is what we shouldn't be doing if we want to optimize the code well. We should be changing the position for an existing graphics object. But for now, since the bodies is going to be dynamic, we're going to be adding new bodies to it. I think this is the easiest option for the tutorial. That's a challenge you can try after, outside of this tutorial, as in creating the graphics outside of this ticker. So I'll show you what I mean exactly is bad in a moment. So what we can do here is iterate over the bodies. Const body of snake.body, and then we have the body, and then we are going to be creating a new body, and then we can set this to the X and we can set this to the Y. We are going to be clearing this body graphic, so remove children, and then we are going to be pushing to this body graphic. So this is what I mean is very unoptimized. It would be better to refer to an existing graphic and then update the existing graphic. It is a little bit easier for the GPU. This is what I challenge you to do outside of the tutorial. So this looks good, I believe. Let's see if this is still working. Yes, nothing has broken. So let's just see if this is doing anything. So we can add some kind of offset here. And now we can go back to the browser, and we have to increase the body by hitting the food. And there we go. We can see that we have the offset of where the snake was, and that is working fine. This little trick that I have to get the snake body to be giving the illusion that it's moving is to be constantly pushing the head into the first element of the snake body and then popping from the body. We can use a function called unshift, which inserts the new element to the beginning, and we can unshift the head of the snake to the body, like so. And now we can remove the last element from the snake body. And then we have it. This is the full logic, how we give the illusion that the body is moving. If you don't believe me, let's check. There we go. Now let's get more food. And we have a snake following us. Let's go to full screen. And we can play more with the snake. So I think this is cool. We have a working snake. We don't have collision yet. And also the food is spawning in one spot. Let's go first and add some random spawn spot for the food. Back up to the top and then add a function called create random coordinate. And this will take in the grid size and then it will give us a coordinate on the grid. And now we can write the code like this, math floor. And here we are creating a random grid coordinate in the top left 200 pixels. And then we can use this function, and let's use it here to create a random head spawning spot with the grid cell size, and then we can use it to create a random food spawning spot, and then we can also use it to change the food location after we eat the food. Food equals the new coordinate. So I believe this is good. Let's check out the browser, and now we can eat it, and there we go, we get another spawn location. And as you can see, it's only in the top left hand corner, and this is because we haven't added the logic yet to see how big the screen size is. So now let's add in the last feature where the snake will be eliminated when it eats itself by accident. What we can do is add the check-in after we move the snake. So here we can check the head is not equal to any of the bodies, and if it is equal to any of the bodies, we know that the snake can be respawned. So this function takes in a callback, and this callback takes in the body. And so this body, we can check if it's colliding with the snake head. So now this function is going to return true or false if we are colliding with ourselves. And if we are colliding, we can set the body array to be empty. And we can also spawn the head somewhere completely else. So create random coordinate, grid cell size, and let's see what this has produced. Now we have to, of course, create a snake long enough so we can at least run into ourselves. Now let's see what happens. And there we go. That works as intended. And I think that's about it for this tutorial. I think I've given the basics on how to make a simple snake game in Pixi.js. And if you would like to learn more, if you have any questions, if you want to see any more features, if you want anything, just let me know. Let me know in the comments, and I'm going to be checking it out. And thanks for watching. I appreciate that you've managed to stick it out this long. Hopefully you learned something new. And another thing, a more advanced version of this snake game is on my website, simplebraingames.com. This code is also available in the GitHub here, and this snake is a little bit more advanced because it follows the cursor. Well, it should. It's not doing it properly. This is something I'm going to work on, and this is my progression of the snake game. And yeah, thanks for watching. I hope you have good luck, and any questions, please ask.